Okay. Can everyone hear me? First of all, before doing my presentation, update from Reza. He fixed the SSL. Okay, he just wanted to show that this is actually secure now, Calico.Ninja. So, yep. And let's go to this thing. Okay, that's visible. Perfect. I'm gonna try this thing. Okay, perfect. So I have a controller from the phone now, so that's nice. So my talk, it's titled Trace It All, OTEL plus Jaeger, which is really hard to pronounce for me, for Go services on Kubernetes. So essentially this is an entire observability platform for tracing, distributed tracing, that I'm gonna be sharing today. So yeah, we're gonna be learning this together. So who am I? I'm Shanky, Senior Platform Engineer. I'm passionate about cloud-native technologies, DevOps, and open source communities. As you can tell, this is one of the communities I organize. I also organize the Cloud Native San Salvador chapter. And I'm a speaker and mentor in DevOps, Cloud, and CNCF communities. If you want to connect with me, sorry, there's a QR code that you can scan, but I have it throughout the presentation as well, if you can catch it. And of course, you can talk with me after the event. We're probably going to have like 30 minutes to talk. This is the agenda for today. So we're going to do a small introduction. Then we're going to do what is OTEL. Then what is the architecture, the benefits. We're going to do a small introduction to distributed tracing. What is Jaeger, the architecture, benefits. And then we have a demo that I hope it works. Today has been a tough day, but I think it works. So we'll see. So introduction. So today we're going to walk through how to instrument Golang application or Golang services using OpenTelemetry. This will allow us to ship traces to this platform called Jaeger and essentially deploy everything and really nicely into Kubernetes. So we're going to be using Kubernetes for this presentation. And the goal, like after you leave this venue tonight, what I would like to transfer to you is why tracing matters, then how all the pieces fit together, which is really important, and then how the workflow looks like end to end, from the Golang code to the collector in OpenTelemetry, and then all the way to the UI in Jaeger. So, and sorry if I'm not consistent with my pronunciation for Jaeger. I'm gonna be probably changing the name a couple times. But okay, what is OTEL? So OpenTelemetry is an open source observability framework for generating, collecting, and exporting telemetry data. So essentially, it's this tool that will allow you to scrape data, then export that data to something else. That data can be things like traces, metrics, and even logs. I'm going to be sharing what we're going to be focusing more into the traces tonight because this platform is quite huge. Like we could spend a long time here talking about like everything you can do with OpenTelemetry, but we're going to be focusing in traces tonight. The nice thing about OpenTelemetry is that it provides you with a language-specific SDK. So you can pretty much plug it into anything. Like if you have a TypeScript service, if you have Node, if you have a Golang, in this case, a Rust server that you want to expose with OpenTelemetry, I'm pretty sure you can with most of the most commonly used languages out there. Tonight we're going to be focusing in Go because I'm learning Go a little bit more. I want to have more experience with Go, so yeah, I'm using it in my demos from now on. So yeah, essentially developers can instrument applications without vendor lock-in. So that's really important. And we're running an open source community here, so vendor lock-in is a really important topic that maybe we can talk another night, but essentially OpenTelemetry won't lock you into paying to somebody because it's pretty, you can pretty much export it somewhere else. Like if you're using Jaeger today, you can later change it to Grafana Temple, for example, or you can change to a different platform. Doesn't matter. Like all the data is going to be used in the same way. So OTEL ensures that there is a standard data model, unify APIs and SDKs across the languages, so you don't have to relearn concepts every time you change language. Extensible exporter, and that was kind of like that vendor lock-in that I was talking about. As you can see, there are some export examples there, like Jaeger, we're going to be talking, also Grafana Tempo, X-Ray. You can essentially use anything, and OpenTelemetry will be able to plug it in pretty nicely. Auto instrumentation. So yeah, it supports common libraries. So essentially, think about it as standardizing your pipeline, but for all your observability signals. So essentially one platform that will rule everything. So this is a simplified diagram, I gotta say, of the architecture of OTEL. In the left side, you have essentially the data instrumented from services and infrastructure. So in this end, we would have like your applications, your backend, or things like that. Then in the center, you have essentially the OpenTelemetry Collector, which essentially is, there's some components to it, like the receiver, the one that receives all the traces data, then the processor, essentially will process all the data, and then the exporter, which will send this data to a backend, where you can pretty much store and then revisit the information later on. So in this case, the exporter is going to be Jaeger, and we're going to be talking about that one. But there's nothing restricting you from having multiple observability backends, right? Like you can even, like if you have a use case for Tempo, you can have a separate Tempo instance plugged into the same OpenTelemetry that Jaeger is consuming, and doesn't matter. Like it will be able to source from everything. So again, this is just the architecture in text, what we talked about. And again, it's really nice that it decouples the apps from vendors, so you can switch at any time that you want. And it supports batching, retries, filtering, sampling, which are things that we're going to be doing today. Benefits, I think this is redundant. We talked about it, but probably something I want to mention from here is that it works, OpenTelemetry works extremely well in Kubernetes and microservice architectures. There's sometimes this problem where with Kubernetes now, everything is so distributed, like there's so many microservices and things, and observability gets a little bit hard to do. OpenTelemetry is kind of like the answer for this, where you can essentially plug this thing and have traces from all your backend services, frontend, sending data to OpenTelemetry. So, yep. Now, this is a really important concept about this monitoring world and everything. What is distributed tracing? So, essentially, imagine that you have a frontend, then you click a button, and that button makes a request to a backend service, right? Pretty common standard process. Essentially, distributed tracing is a method of tracking this request through multiple services layers in a distributed system. So if you had, for example, the frontend hits a backend API, and then this backend maybe hits another backend API or something, you would be able to see this with using this tracing, distributed tracing. And I'm going to show you how it works in the Jaeger dashboard. You can actually see it, like which applications are talking to each other. And the important thing is that distributed tracing gives a request, every request a unique trace ID. So with this trace ID, you can essentially follow through a request in your system. So it also helps you doing things like debugging in production, right? Like for example, I don't know, a customer click buy here, it charges them the money, but maybe they didn't get the item they paid for. You can trace this request and see where it failed. So that's kind of like the power of this. Now that I think about it, it would have been nice to have like an error case, but actually the demo is kind of happy path, everything is successful. But for the next one, maybe I'll do something that fails, a request that fails, and then we follow it through and we debug it. So yeah, let me see. Yeah, so why do you need it? So because we need to understand how microservices interact. And this is really important in today's day and age, where every time we need to do a new piece of code, we almost always default to, okay, let's create a new microservice. And then you start expanding your architecture a lot into this distributed system, and then at some point, people don't really understand how things are talking to each other, right? So tracing helps you with this. It will allow you to essentially trace your requests into all the microservices. It also identifies slow or failing components. You are able to essentially detect bottlenecks, right? Like when I click this button in the front end, hits the back end, and maybe the back end does a request to a database, you're able to see, okay, it seems like the bottleneck is in this specific component. So that's really important for big systems, which goes along with see where the time is being spent. And debug issues that logs alone can't uncover. Sometimes we are relying a lot in logging, like reading the logs from the application, but sometimes the logs won't tell the whole story. It will probably tell you things like, oh, something called this in this endpoint, and you get this log. But if your logging sucks, like if you are not actually logging proper errors, it will probably help your journey of debugging, right? So tracing can help you with this. Let's see. So this is kind of, I hope this is a good explanation of what tracing is, and then we're going to be talking about what tracing, span, and the context propagation is. So imagine trace being the full story about your request. So it'll contain everything, like from the moment you hit the request, all the way till you got a response back, like a 200 code, HTTP code, or whatever you're hitting. A span is a chapter in that story. This is a diagram I found online, and I really liked it, so I stole it from somebody. But yeah, essentially you can see here, like the trace is the entire request, and then your span can be like, oh, I hit this endpoint, and this endpoint triggered this thing, and then it did another thing. So your spans are each chapter in this full story. And then the context propagation is how services pass the story along. I hope that makes a little bit of sense. But yeah, essentially when you get into a request, you have a unique ID, and then your context can span into multiple requests when your system is a little bit more distributed. But for today, we have a pretty linear demo. Like it's just a front end that hits a backend, so you won't be able to see this kind of context passing, but I hope that is good. So what is Jaeger? We're getting close to the demo. So Jaeger is an open source distributed tracing platform. It was originally developed by Uber, but now it was donated to Cloud Native Computing Foundation. So I think it's a graduated project, if I'm not wrong. I hope it is. But yeah, essentially helps diagnose latency, bottlenecks, and failures. Integrates pretty nicely and natively with OTEL. And it provides you with a simple UI to inspect traces, spans, and timings. So the architecture, in this demo, we're going to be using the unified architecture. So everything is kind of contained in the same pod because I'm just running a kind cluster locally. But I think there's a microservice architecture for Jaeger where it's going to split the components and allow you to have multiple, like HA, right? Like, so your platform doesn't just die. But essentially, Jaeger is composed of several loosely coupled, horizontally scalable components. And Jaeger does not instrument your code. So this is really important. Like this is just, Jaeger is just the backend. So it's just storing your data and then displaying it to you in a really nice way. So the job for Jaeger is to receive traces, store them somewhere. In this case, we're using a Cassandra backend. So there's a database where Jaeger is connecting to, and every time it receives a trace, it pushes it to that database. For demo environments, you can even you don't even need Cassandra. Like you can just store things in memory. Like if you're a demo, like just doing a demo or testing. So it's going to be a lot simpler to deploy, a lot simpler to maintain. But if Jaeger dies and you have everything in memory, obviously your traces are gone. So if you're doing it in production, get a database and store your data properly. And then the third job that it does, it's serve the traces to the UI. So this is kind of like the most beautiful part of Jaeger, in my opinion, because it will allow you to follow those traces. And this is a visual way for how Jaeger works. So essentially, you'll have a Jaeger UI, and then there's a small collector that is talking to the OTEL collector. So this Jaeger collector will essentially push the data to the DB. So you can do Kafka as well. You can do Kafka, Cassandra. You can do in memory, like I said before. I think you can even do ElasticSearch if I'm not wrong. I could be wrong, but I think you can. And then Jaeger does the queries and then shows them in the UI. So this green box right here, this is your Golang application for this demo. Then the OTEL collector collects the data from that application, sends it to Jaeger, Jaeger stores it, and then serves it in the UI. This is something important as well. Like you could even have OTEL getting data from Prometheus as well, from a Prometheus. Like because some applications have like the metrics endpoint where they get like stats for CPU, memory, and RAM, and it's pretty standard to have it that way. You could even get the data in Prometheus, like scrape that data with Prometheus, push it to OTEL, then have OTEL push it to Jaeger. So it's like there's endless possibilities in this for what I've been learning. A little bit of the benefits, end-to-end visibility across all the microservices. So again, you're going to be able to see and understand your microservices, how they're interacting with each other. Faster debugging and root cause analysis. Instead of going through logs and trying to understand how the application works, you have the UI, you can figure it out pretty quickly. Identify performance bottleneck, again, really important for big systems where if a request is taking more than 100 milliseconds, it'll probably break your system. But you might want to identify the bottlenecks, right? The visual trace timeline, this is part of the UI. It's really nice. It will show you like how long it's taking, depending on the service you select. The dependency graph. This is something that I couldn't get working for this demo, sadly, but when you deploy it and have a proper Cassandra table, it'll start with using the traces. It will start understanding how the services talk to each other and kind of like create a map of all the dependencies. I couldn't get it to work, sadly. I had problems with Cassandra, but we're going to be able to see everything else. Reduces need for excessive logging. Logging is kind of expensive as well. So yeah, the storage of logging, reading, understanding logs, creating dashboards through logging is kind of painful as well. Like there's some companies out there that parse log to get dashboards in Grafana, things like that. Like this is 100 times better, like if you used to do tracing natively. So for the demo and code, I have a repository. You can take a picture of this if you want. I essentially have a repository called talks, where I push all the talks that I've been doing. This is pretty new. I just have 2 talks uploaded there, but my plan is that I'm going to centralize all my repositories into this single one because it was becoming a little bit of a pain to handle too many repositories. But yeah, let's do this. So essentially, this is the repository. Let me show this, yeah. And the way to navigate it, you essentially can just go all the way down and then OTEL Jaeger Go Services, you can click this guy and it should send you to the folder that I'm gonna be working on. Just if you are interested, you click that, you get to the folder, you can read all the code. I have instruction in how to run the application and everything. I'm becoming obsessed with makefiles, so everything is orchestrated with makefiles now. But yeah, I'm essentially in that folder that I opened. I'm in November 19 OTEL Jaeger Go Services, just so it's easier to navigate. And I want to talk a little bit about the folder structure here. So yeah, I still got a couple minutes. So let's start from the outside. So the first thing is your makefile. This is gonna be orchestrating everything. So if you want to run the demo, you just need Docker, install Docker, and then essentially you can run make all, and it's gonna start creating a cluster in kind, and then deploy all the applications and build all the applications, deploy all the dependencies. There's some other commands here as well that are really nice, like to pour forward Jaeger, and we're going to show that UI, pour forward the application, things like that. That's essentially it for that one. Then we have the configuration folder. So this is a tool I'm using for this demo. It's called Helmfile. So Helmfile is kind of like a wrapper for Helm. It allows you to do things a little bit more nicely than with the regular Helm, because, for example, here I'm essentially creating a single bundle of everything, and I'm installing it with a single command rather than doing like a Helm install OpenTelemetry, Helm install Jaeger. one for my application. I can essentially bundle everything in this Helm file and get everything created. So the way this works is you need to specify the repositories that you're going to be using, the Helm repositories. We have some defaults. In this case, I'm setting the Helm diff command to be this version. Then this is how you specify your releases. So we have the Jaeger release. We have OTEL, your backend and your frontend. And I could have spent a lot of time talking about how these Helm charts are set up and things like that, but essentially all you need to know for tonight is that if you go into the values folder, there's a values file for each of the applications. So there's one for Jaeger, and it has some extra init containers to wait for Cassandra to be up before it runs Jaeger. That helps you orchestrate the things a little bit better. This will essentially run that Jaeger and Cassandra. Then after that, these things run in order. So it'll run Jaeger first, and then it'll run OTEL. So for OTEL, we also have, sorry, let me open the Helm file. We have OTEL on this side. It's pretty simple. It's just the endpoints that we're going to be using, the exporters that we're using, how we're going to do. I was doing a little bit of debugging to fix some issues, so verbosity is detailed, but you can remove it and it'll go back to the default, which is a little bit more quiet. So that's all for that. And then I have two services. I have a backend and I have a frontend. So remember, these are just the values files. So the manifest for this is actually using a Helm chart. And this Helm chart is using a library. So library is this a little bit of a newer concept in Helm, where you can essentially create a Helm chart that just references a library, and then you're able to inject all the manifests and just send your values. So I'm using this chart, which is called Helmet, which is kind of like a template that allows you to deploy any service, because I didn't want to build my own Helm chart. So this is the Helm chart, and then I pass the values for each of my services. And the nice thing about this is if I wanted to deploy 1,000 services, I don't need to be changing the Helm file, the Helm chart. I can just change the values and deploy as many services as I need. So yeah, and something that you're going to notice in both my frontend and backend is that there is a variable here for OTEL exporter OTPL endpoint. So this essentially tells send the data to this OTEL instance. And the OTEL service name is also an important one, because this is how OTEL is able to tell, okay, this is the application that is pushing the data. And random things that you will always see in applications, like your ports and things like that. Still good with time, probably about 5 minutes. So yeah, essentially, you deploy this thing, and with make deploy, and it'll essentially, you're going to end up with a state like this. You have a namespace called monitoring, which has Jaeger. It has Cassandra in HA mode. So this takes a little bit to start, by the way. It takes like 5 minutes, I think, because it has to start all the instances of Cassandra and make sure they're synced. So yeah, just watch out for that. And then you have your OTEL collector for OpenTelemetry. And again, I'm using the really simplified versions of these tools. Like a single deployment has everything, but you can run this as a microservices where you are going to see all the components, and that's better when you're trying to do production with this, because it won't, if a pod dies, it won't essentially kill everything, right? So some things that you're going to notice right here is that I'm doing some port forwarding for the application. There's a front-end application, and I'm also doing a port forward for Jaeger. So if I move to my browser, there's this little front end. It's quite simple. Again, it's just a button. When you click it, there's a request that goes to a backend. Backend comes back with some random words, and then it'll display them here. And then this is your Jaeger UI. So before I show you this, I just want to talk something really quick about the application side. So pretty standard. We have a Go application. there is a small Docker file. Then there's a small application. This is the SDK I was talking about, where you install the Go SDK for OpenTelemetry. And then you're essentially able to wrap your handlers with OpenTelemetry, right? So you can see that I have these routes here for words, health, and essentially I just wrap them with this OTEL HTTP new handler function, and then I pass in the name of the trace that I'm sending, and this essentially tells OpenTelemetry, okay, every time that somebody hits this request, this is gonna be the name of the span in the UI. And this is how OTEL is essentially sending this information to Jaeger, and then Jaeger is able to display that information. And then, yeah, you see some really simple login here, like backend service starting on, and then your OTEL endpoint, which is the variable that we defined in the values file. And it's pretty much the same as well for the frontend app. Obviously, you're going to see some nested HTML in here, little template. And yeah, essentially, we're just doing gRPC requests to the backend and pretty much, yeah, sending back that and also wrapping things in OpenTelemetry to extract that trace context, right? So,
is it a common endpoint for a front end and back end?
It is, no, it's different endpoints. We have some endpoints for front end and some endpoints in the back end.
So for each service you have
traces. Yeah, you have one trace for kind of each endpoint. Yep. And you can decide this, right? Like some developers will probably only trace the most hot endpoints, if that makes sense. Like the ones that are mostly used, or some people will decide to trace everything, essentially expose all your endpoints to OpenTelemetry. And yeah, the way the UI works, this is the part that I told you I wasn't able to get working. Probably for the next demo, I want to have this one working. But this shows a really nice UI and how everything talks to each other. But we have this, which is kind of like the core component of OTEL, and of Jaeger, sorry. So again, this is the name of the service that we set in the values file. So you can see the backend service and the frontend service. So I'm gonna do the backend service, and what you see here, the operations are essentially those endpoints that we set, like the traces that we're sending. So in this case, I think I'm gonna get all for now, and we're gonna see how it looks. So it's gonna quickly allow you to identify how many of the queries have been run in a certain given time. And you can even, you can go more than this. Okay, but we don't have 20. But essentially, every time I generate words here, I'm hitting the backend, right? So I go to the front end, and the front end hits the backend, and then it sends the request all the way there. So if we refresh the traces here, you're gonna see, do you see this span that I did here, out of 6 requests? We can even click it, and this is the story I was talking about, right? So this is where I want essentially to show you how everything is connecting, if the dots make sense. So we have the front-end service. I'm hitting the front-end service. Then there's an API word handler, and the button that I'm clicking to generate the words has the function fetch words from backend, right? It hits the backend, and then the backend service has an endpoint called words handler, and essentially it's displaying the whole story, right? From when I click the button all the way till I got back the response, and you can see that it took 27 milliseconds. Things that you can see here as well are the HTTP targets and methods that I was using, and the response back. So in this case, it was a 200. Let me show you a different way to see this. If you do this one, I'm gonna do front end. I'm gonna choose this guy, and there is a trace graph. Okay, so this is pretty hard to see, but again, it shows you kind of the same story, right? And how it's going and flowing through services. So if I had something more complex here, where maybe when I hit the backend is talking to 3 microservices, I would be able to see all that data, right? So this is kind of like the big deal, like why tracing is important. Because when you're starting your company and like you just have a couple applications, everything is fine. But when your architecture starts growing, you start having more microservices, you're going to notice that it's really hard to control and to understand your platform. So these tools like this can help you pretty much understand your service. And then there's this flame graph as well, which was essentially show you what is taking more time for your request. So in this case, I need to make my words handler from the backend a little bit more efficient. It's taking 110 milliseconds. So yeah, you can essentially see where you're spending your time. So yeah, honestly, that is pretty much everything I had for today. I don't know if there's any questions. Yes, Dolan.
Thank you for the presentation, Shanky. I just wanted to know if this one is using Elasticsearch, because if yes, like it would be easy to feed the logs to Wazoo, and that would be awesome for me.
Not in this one, but you could. You could connect Jaeger to Elasticsearch. Yeah. In this case, we're using Cassandra. Yeah, which is a NoSQL database. Yes.
The only times I've used OpenTelemetry,
Yes.
the first thing I always remember is that it was in embedded systems, and I would always run into very quickly run into like performance constraints. This has been something I had. So basically, like I would run like a service, and like the OTEL stack would take up as much resources as the service itself. So yes, I was seeing like how long things took, but I also made everything slower by just running a system in the background.
Yeah.
This is something that's been addressed, and it's just been like 5 years ago. So has it been addressed?
I would hope it's been addressed. I haven't heard any reports, and I've seen this OpenTelemetry stack running in really large systems. So I think it probably has been addressed. 5 years ago, I'm thinking that was more beta, so probably wasn't like as production ready as it is right now. But yeah, that's why you can still choose to not wrap all your requests, right? Like you can decide which endpoints you want to push. That might help you as well, reduce the timing. And you can essentially, maybe it's a feature flag as well, right? Like you could feature flag only specific endpoints, and then if you're turning that feature flag for a period of time, you can use it to debug in production, and you can turn it off. Like there's a lot of possibilities here. Thank you for the question, really nice. Any other questions?
So in the last Jaeger UI,
Yes.
The front end, you trace from front end and then to the back end.
Yep.
So how does it connect the front end core to the back end core? Like you click the button on the front end, and then why is that request to the front end and then connect to the to the back end?
Yeah.
Is it rely on the context, or
There's a level of context that Jaeger is getting from the spans and how they're interacting with each other.
But how does the context pass from the front end to the back end? Like,
That's part of the OTEL, the OTEL magic. Like that's coming from OTEL, where like the OpenTelemetry is essentially scraping all this information. Well, your applications are sending this information to OTEL, and remember there is a level of connection that you're displaying in your applications, right? Like when you click the button, like hit this endpoint. So let me see if I can find that thing. So yeah, essentially you can see like there's some connection between these things, and at the end when you wrap things, I'm not gonna lie, there's a lot of magic here, but OTEL is able to essentially glue everything together, like understand how the request is flowing through the system, and basically piecing everything together based on the request and the spans and how they interact. And also this is using local networking in Kubernetes, right? So even at the networking level in Kubernetes, we have that ability to understand these services hitting these things. So to be honest, I don't know 100% if this is how it's working, but I'm pretty sure that there is some networking magic here happening to understand, oh, I'm hitting this service. I see that this service has this span, so it's connecting everything together.
okay. So I guess you have to wrap both the front-end endpoint and back-end
Yes.
with the kind of the same instant of
Yes.
OTEL, right?
Yes, if you don't wrap both, then yeah, the story is pretty much, or yeah, the story is not going to be complete, right? Yeah. Any other questions? We good?
So I have a question. So you mentioned in one of the slides that metrics are one of the features that OpenTelemetry supports. So
Yes.
is it mature enough to replace something like Prometheus, or?
Yeah, I think you can work with both together. Like they each have their strengths, in my opinion. Like in the system I run in production, we use both, where we have OpenTelemetry for the application stack.
Same, exactly. That's
Okay, yeah.
For metrics, we mostly rely on Prometheus. Like if we want to calculate.
Yeah,
like,
honestly,
latency or-
I find Prometheus to be better in metrics. So that's why we run Prometheus for those kind of requests. But yeah, for application side, we haven't been able to find anything that replaces OpenTelemetry with this level of detail, pretty much. Yeah. Yes.
Forgive me if you just answered this and I didn't
All good.
understand. But so this does require like instrumenting your code, right? You can't just.
Yeah, you do. Yeah, sadly, this is not plug and play like other things. Like I know there's some paid solutions out there that might be more like, oh, you just bring this library and it's gonna read everything and you're good. But no, you need instrumentation. So you need to change your code a little bit to essentially tell, okay, yeah, send this spans to OpenTelemetry. So yeah, it's not as plug and play, but it is pretty developer friendly. I'm not a pro Golang coder, and I pretty much figured out like just reading the documentation. So yeah, thank you for the question. Good. Okay, so thank you so much for that. One more time, if you wanna take a picture, like see the demo, run it by yourself. Like don't let me fool you. Maybe something is breaking. Create an issue in the repo if something is not running as expected. I do still wanna. I will still push more things. I wanna get the dashboard working properly for the dependencies, and then maybe take some screenshots of that. So I'll be pushing more for that. And thank you so much.